And you were saying before we came on air that the weather in Melbourne is actually surprisingly warm for this time of the year.
I wouldn't say warm, but it's surprisingly good.
Okay. Andrew here from Not an Audiophile. Thank you for listening. Today is episode 5, season 1, and we have Jon De Sensi from Melbourne, from OAD Ultrafidelity on the line, and Brad Serhan in Sydney from Serhan Swift. John's a very interesting guy and a very smart fellow. Beautiful amplifier, preamplifier and power amp combination. A beauty to behold and sounds delightful as well. So without any further ado. I have met you briefly, Jon, once at a show. You showed me the pre-power amplifiers, which you're going to pronounce the names of shortly, and I was staggered, I think is the word, with the...
Oh, really?
Well, absolutely. The fit and the finish, the design, the industrial design, it's an absolutely world-class product, and certainly one of the key reasons I wanted to have you on the podcast was just to discuss how the hell you could make that happen, because my understanding is that you make the vast majority of the product in this... Well, you make it in this country, but you use predominantly locally made sub-assemblies and parts and what have you. So, and Brad, I know, wants to talk about the more technical side of it, the nuts and bolts of your transistor selections, apparently. So, we'll get to that.
I have very limited knowledge in that area, Andrew. I'm going to leave it to you and Jon to discuss that. But anyway.
Well, we're not going to... Let's not turn it into too much of an electrical engineering discussion, but I guess...
Sure.
From a potential buyer's perspective, I mean, there's a key thing, and that is that it's made in this country. You designed it, we believe, and I'd like you to tell us how that even got. How did it happen, and how did you get started? In 2 sentences. Where you go?
In 2 sentences.
Now take as long as you like.
Well, we did make some more humble chassis, which are also on the website under the discontinued equipment menu, and people really loved the sound, but they thought that the appearance didn't really quite match the sound. The appearance is, a bit like your sort of, 80s, 90s audio research, nice CNC front panel, and then sort of folded metal chassis. And during COVID, I had a lot of time on my hands, and a customer of mine, someone who became a customer of mine, contacted me and said, "I'm a shit hot CNC machinist.
Okay,
I can't afford your equipment, but I can design you a really nice remote control.
Okay,
and maybe we could do a bit of a barter." And eventually, we redesigned the preamp and the power amp. Now, the preamp is called the Padma, and the power amp is called the Vajra.
Okay.
And there's a little bit of a story behind those two. Yeah.
Well, the spelling is pretty much as it sounds, actually. So not as complicated as I thought. So interesting. So that's, to some degree, you sort of fell on your feet a little bit with that incredibly high level of CNC finish. Is that right? Because the guy rang you?
Yeah. Well, actually, he emailed me.
Okay.
And I just ignored it because I get a lot of because I get a lot of not a lot, but I get a few emails where people just want things for nothing, or they want things, on the cheap. And I just thought he was just another nutter. And then I did the Melbourne audio show in 2017, I think.
Yeah, okay, yeah.
And I met him, and we just hit it off from the very first minute, and then it turned out that we're actually 8 minutes away from each other's houses.
Okay.
And we've become the best of friends. We probably are the best friends of each other. And
wow.
And,
so that's
we're constantly at each other's houses every week.
okay.
So, yeah.
Oh, that's an amazing story. Okay, so that well, I guess
So it was meant to be.
It was meant to be, and it goes some way, I guess, to explaining just how the finish ends up as good as it is. And for those that are maybe listening and not sure what we're talking about, it's OAD Ultrafidelity, and I guess the web address is literally that, with a .com and a .au on the end of it.
Just .com.
Just .com, okay.
Yeah.
Huge international company that, it's too big for a .au. And, I mean, it's OAD Ultrafidelity.com. And I would have a look while you're listening at the podcast, and then you will see what I'm referring to. Although to see it in the flesh is the go. So I'll cut to the chase before I forget. So Melbourne Audio Show this year, on in a few weeks, although by the time this episode gets up, on in 2 weeks. Maybe it takes a week or so for us to edit and upload it. So Melbourne HiFi Show any minute, early to mid-October. I think maybe it starts on the 11th or something. And you're going to be there. I hope you're going to say yes.
Yes, we will be there.
Oh, yeah. Excellent. Okay.
And this time we won't have our own dedicated room. So Nick Holgich, who will hopefully be on your podcast before too long, has been begging me for years about doing a show together. So
okay.
we're sharing a room, and I won't have my open baffle speakers at that particular show.
But you'll clearly have his speakers, which are, of course, excellent.
They are.
They are.
And we've done a trial run just a couple of weeks ago, and I'm excited about sharing the room.
I was going to say, having heard his speakers maybe at the same show last year as you were at, where I first discovered your amplifiers, because I think you were like almost diagonally opposite.
We were.
Yeah. There was some reason why I just went, well, I could see something through the door there. I'm going to go and have a look at that. And so I spoke to Nick and heard the loudspeakers, and I'm going to forget which model, but I tell you what, I scuttled back to my own room to make a quick comparison and was glad that our loudspeaker was a little less expensive, because his are very, very good, and of course stunningly well finished, and I know that he goes to some considerable trouble, well, with all aspects of the design. But yeah, my oral memory of the balance of his loudspeaker, and I'm honestly forgotten which amplifier he had it on or what amp, but I tell you what, I reckon your two might work well together, and that's what you've found so far, is it, John?
That's correct. So yeah, we did a trial run. We're also sharing the room with Stavros Dakman,
okay,
who imports a lot of Chinese made equipment, which is very good.
Mm-hmm.
And we
now,
got together.
This show's all about Australian-made stuff, so that's actually the wrong thing to say. So if we could just...
All right.
No,
Rewind.
Keep rolling. Okay, so there's three of you in the room.
So there'll be three of us in the room. Yeah.
Well, you have lots of stuff to look
at. But predominantly right up like in people's faces will be Nick's beautiful speakers, which he's modified since last year, and they sound even better.
Okay.
And they work better in the room, and my amps, which are identical to what was at the show last year.
Yeah. Well, yes, and which room? While we're on the subject of the I think it's called the Australian Hi-Fi Show. I think that's the correct title.
Is it StereoNet?
StereoNet Australian Hi-Fi Show.
Hi-Fi Show.
Oh, it's quite a title. The and the Pullman Hotel across, in Albert Park, across the road from the lake, not hard to find. I think everyone who's listening who lives in Australia will certainly know where that show is. It's been in the same location for some years. What room are you in, John?
We're in room 2313.
2313, okay.
Yeah.
Well, we've got that covered. Now, how... electronically, your knowledge is extremely high, but how far back does it go, and how did you end up designing amplifiers?
It's a bit of a long story. The genesis kind of began in the 70s when my father He was a great music lover from Europe who loved his classical music and opera, Italian opera. Bought a pretty flash at the time Sonio 4-channel stereo system. It was a big cabinet with the turntable and a receiver, and space underneath from what I remember, and then 4 speakers. So it was actually a quadraphonic system.
So this was 1973 or 1974, which was
1974, I think, and
big year for quad.
It was
quad surround sound, or whatever we should call it, not quad as in electrostatics and what have you, but quad the thing, not the brand. I mean, it was almost, like Dark Side of the Moon or something was the quad album or something like that. I mean,
Well, you hit the nail right on the head, because I was just going to say my brother brought home a CD4 or 4-channel version of it.
Yeah.
And we popped it on the Sonio turntable, and we were just completely gobsmacked by the sound at the time. And I'd already had an interest in electronics, but it became greater and greater from that point onwards. And I couldn't afford obviously my own system, but I occasionally friends of mine had bought Japanese equipment, nice sort of Onkyo or Sansui, 2 of the better brands back then, and I'd sort of buy the service manuals, and we'd go through the
service manuals. Okay, so this is interesting.
as a 12-year-old. Yeah,
is that a fact? Wow. Okay, so
that's right.
So you get the manual, as we say in the trade, we just call it a manual. You get the service manual, and you, I mean, the circuit was probably all on one flip-out page or something at that point, and or sometimes they even folded out, to 4 sheets worth. So you would have just loved that, I guess, as you would have just been examining that in its finest detail, and I guess trying to understand what each part of the circuit was what its function was. Is that the case?
That is exactly correct. And I had a bit of an ace up my sleeve, because one of my primary school teachers was a fully fledged electronic engineer.
Wow.
Who had actually worked for the prestigious Telecom Labs.
Okay.
And had written lots of papers that ended up in IEEE. I didn't know this at the time, of course, but he also lived just around the corner, and that's where my electronics interest sort of developed. And we were developing more sort of cheeky little sort of mini kind of CB radio, so we could actually talk privately amongst our friends at school.
I love it.
Because we used to get told off about being on the telephone for hours.
Of course.
So we built these little 5-watt transmitters.
Wow.
On the shortwave band. So we'd buy shortwave radios and we'd tune in.
Yeah.
To each other's frequency and have a bit of a talk.
Yeah. So you sort of like you'd have a. Well, it's better than it. So you duplex frequencies or something, or what were you transmitting on?
No,
something or other and listening. Yeah, okay. So everyone's listening to this.
So we'd actually we'd have to have our conversation.
Yep.
And then turn off the transmitter and then turn on the shortwave radio so we can actually listen to the other person have a go. And then
I feel like we've got a great big convoy going on, actually, John. Yeah. Oh, roger that, good buddy.
Yeah, that's that's amazing.
Fantastic.
So
what? It was all illegal, of course.
Oh yeah, highly illegal. And in those days, of course, as you could confirm, I guess, I'm guessing Melbourne was the same as up here. But yeah, the radio inspector, used to drive around with about 12 antennas on his car, looking, listening for illegal transmissions. I mean, sort of like a high-tech version of a parking inspector, I suppose. And
yes, exactly.
So you didn't ever get pulled up by him, though?
No, we didn't, luckily. No.
You know what's hilarious is that there's no such thing today as the radio inspector, I'm going to guess. I mean, you could literally start your own radio station, and it seems like you'd, for a while, get away with it. Is that maybe not true, but...
I think I think that is true, and unless there probably is someone, but they probably sit in an office or by themselves 5 days a
because
week.
they have no friends.
Exactly.
I've just looked it up, gentlemen.
Yes.
And I just looked up. I love the fact it's ham radio, which sort of is, what a great name. I want to know the derivation of ham radio, but you must be qualified to operate an amateur radio and operate under a license. There are also rules for the equipment.
On an amateur band. But what about if you just go, because I'm sure you can buy transceivers that cover just about every frequency up to, I don't know, into the gigahertz, I think, and you can just open a microphone or plug in a signal and, obviously you'd do it on the FM band so people could listen in, I guess, but I don't think anyone cares because everything's on the internet, so including FM radio.
True.
Yeah, I think if there's a bit of splatter on someone's television or radio,
right.
Then if they're smart enough to contact the local authorities, you might get busted. But the chances of that are very, like you said, because there's so much streaming and listening on radio and mobile devices. I'd say your chances are pretty small.
Well, yeah, that's another angle, isn't it? That people forget that there's so much transmission anyhow. Yeah. So look, so harking back to the local radio net or whatever you might have called it. So that's where you clearly got a start in electronics, was or designing things from scratch, or this transmitter that it was some sort of standard circuit out of, I don't know, Electronics Australia or some UK or American equivalent of that. Is that how that worked?
Well, actually, it was a design from our science teacher, who
of course it was.
who was the electronic engineer who lived around the corner.
Oh wow, yeah,
Proximity effect. I love it.
And, he'd resigned from Telecom Labs because his mother was sick, so he needed to be a bit more local. And so we were the beneficiary of having this, highly intelligent and articulate person who actually spent his lunchtimes teaching us electronics, because that wasn't a standard subject back at primary school and high school actually.
It's a bit of a coup, isn't it? Really, and
absolutely.
Then that set you on that. I mean, there's many things that set you on the path, I guess, towards electronic engineering. But that's. I mean, you sort of lucked in there, didn't you?
Yeah, it was absolutely. I can't believe my luck, because I had no interest in just about anything at the time, and that was the only thing that kind of I became very curious about. And,
sure.
And it's become a lifelong,
addiction,
a loving relationship, and addiction. Yeah.
Well, it kind of is, and I'm not quite sure why, but I guess it's a certain personality type or something is attracted to the mysteries of electronics, the things that you can't see, but you can make things happen with it. So how did things advance from there? So this was early high school or years? Yeah,
I was still at high school.
Yep. And you at some point you finished high school, and I once had an interest in radio, but it disappeared at about the age where I discovered other things were more interesting. So you continued on your interest in radio, or did you quickly move sideways into audio, or did you just basically chase ladies? What was your...
No, I wish I was chasing ladies, but I didn't have the foresight at the time. And my tunnel vision kept me in electronics.
Okay.
No, we did move sideways into audio because, as fortune would have it as well, one of my best friends at school, who was part of this group of illegal radio transmitters at the time, his father actually was an electronics serviceman.
Okay.
And he would service, TVs and almost anything.
Yeah.
And so we started like getting discarded, Japanese amplifiers, and then, like I said, ordering service manuals and then going through them and then modifying them and making them, sort of bringing them up to sort of what was then being put out by the Americans and the Europeans in high-end audio, that sort of grade.
Okay, so
Wow,
I
interesting.
think people who have an interest specifically in better audio equipment would wonder in the 70s, because this is the late 70s or very early 80s at this point.
Late 70s,
Late 70s.
early 80s.
So
yeah.
what kind of modifications? Or is that something you've long forgotten about?
I probably don't recall all of them, but the main ones I can recall is all Japanese equipment, even today, always include an input capacitor. So, because they're worried about DC coming in.
Sure.
So we eliminated that. And then there would be a little bit of, potentially a little bit of drift and DC at the output. So we would then insert resistor or a potentiometer actually in the emitters of the input stage and trim out the DC.
Sure.
Later on, we got a bit clever and we started putting in what's called DC servo loops, which kind of automatically tune out the DC or zero out the DC from the output.
Yeah.
We replaced every type of capacitor to a polypropylene if we could, or a high grade electrolytic, audio grade electrolytic,
so
I think that was pretty much
that
it
was the
at the
guts
time.
of it, yeah. So yet again, the capacitors, copper hiding, poor old capacitors. You wouldn't want to be one, would you? I mean, they're constantly either failing or being told they're useless. So what? These are not necessarily just electrolytic capacitors in the signal path, though, because there'd be really not many of those, I guess. So what other parts of the circuit do you feel the poor old, the much hated electrolytic let the side down?
Like I said, there was always the one electrolytic bypassed if it was a really good Japanese amp with a polyester or something in the input, so that would get completely removed and made DC coupled. And then there were the odd electrolytic, on the power supply rails, as we call it, and the plus and minus rails. And then, of course, the big ones are the big electrolytic capacitors in the power supply. Partly because the Japanese tended to undersize them, and and if you do, I realised this later, but when I actually got my degree, that if you do an AC model of an audio amplifier, actually the power supply capacitors are actually in the signal path. If you're just looking at it on a schematic and looking at it, from just a signal point of view in DC rails, it's not that obvious. But actually, the electrolytic capacitors in a linear power supply are actually in the signal path. If you do a complete AC analysis, which is actually what you're hearing, you're hearing AC going through the amp. And so that makes a big difference.
Yeah. Because they're not regulated as such. Is that the?
Yeah, that's right. They're not regulated.
Yeah.
Exactly. Yeah.
So that's interesting.
Especially in a power amp.
Yeah, I'm not sure I've heard it presented that way before, but that makes complete sense. Okay, so very interesting stuff. So I guess we don't want to skip over the 20 odd years that might have occurred between flipping open Sansui integrated amp manuals and working out modifications, and then we don't necessarily want to jump forward to today or what. But at some point, or maybe what I'm trying to say is, how long has OAD been operational for, and what happened between the start of that company and in other words, what were you doing for a buck post university? You implied you got a degree in some kind of engineering, I'm guessing.
Yeah. So we got a degree in electronic engineering.
Yeah.
And pretty much right at the end of fourth year, there was a whole lot of jobs that opened up in for Department of Defence, a little section called the Engineering Development Establishment, EDE, at the time.
Yeah.
This is back in 1988, I think.
Okay.
So I jumped into that position and got my start in designing man-pack radios, actually, for the Army.
Okay.
So we had a big the Department of Defence had a big contract with a now non-existent company from the UK called Plessey.
Oh yeah. Yep.
And they'd won the contract, and it was, I think the project was called Project Raven, and they had, they were designing man-pack radios. So whilst they did a lot of the design, we did some of the design here in Australia.
Okay.
And I was brought into that team, and we kind of completed that after a few years. I sort of came in the middle of it, so I got a couple of fun bits to design, and and then after a couple of years, I decided that I didn't really want to work in the defence sort of industry, so I left and went backpacking overseas for a couple of years, and then upon my return, I joined the Bureau of Meteorology, which is as a radar engineer.
Okay, so not as the storyteller that makes up the fantasies about what the weather's going to do. Okay.
No, my legs weren't good enough to be on television to call out the weather.
That's a shame.
Well, back then, I think...
I always thought you had lovely legs.
Well,
actually,
I
John.
think
just a little bit on the hairy side.
I think in those days, they didn't really do the live cross to the bomb like they do now, where they seem to have a broad selection of different people that like to speak on air. But back then it was they just put out a forecast, and it was sucked up by the radio and TV stations and newspapers, and you never really knew where that forecast came from. It's only in the last 15 or 20 years, I think, the bomb has come out of its shell, so to speak. In that time, though, they don't seem to have really gotten any more accurate. But anyhow, that's another story. So you actually stuck with RF there for a while, working with Plessey radios, which I think every taxi in Australia had one in it in those days, or was it?
Yes,
there was
taxis and police, and
okay,
probably ambulance, fire services, I would imagine.
Yeah, it was a big brand of two-way radio.
I think they had Motorola. I think was one of the main suppliers from memory.
Yeah. Okay. Oh, yeah. Yeah. Well, I mean, I certainly saw them, but I never got involved with fixing radios. It was strictly audio all the way. So you decided at some point you got out of the Defence Forces. You're involved at the bomb, but I got a feeling there's other than a background music system, there's not a lot of audio equipment requirement at the Bureau of Meteorology. You were fixing radars, so even higher frequencies, I guess. I mean, what frequency did radar operate on in those days?
Well, they still operate on the same frequencies. So most countries, including Australia, we have two. There are two bands. One's called C band and one's called S band. Mm-hmm. And C band is around the 5 gigahertz.
Wow, geez, that is high.
And well, the reason why we have two different frequencies, I think the S band was around just above mobile phones. I think that's sort of 1,500, 1.5 gigs.
Yep.
And the reason being is because of the different wavelengths. Actually will pick up different size sort of ice particles in clouds.
Oh, okay.
So one can be better than the other depending on what's in the clouds at the time. So we tend to have two types of radar systems.
So
and that's roughly about the time that I met Brad for the very first time, because on the side,
I have this vision. I don't want to cut you off, but I will.
No.
So I feel like Brad turned up at the Bureau of Meteorology with a frozen chook. And he asked if he could sit it in front of one of the radars.
Andrew, you got it wrong. It was the golden goose. The goose that laid
I'm
the
just
golden
wondering,
egg.
at 5 gigahertz, I mean, what are microwaves? Like, as in, what's a magnetron put out? Is there any way you can cook meat with a radar, is what I'm saying?
No. You can certainly. I don't think the power was, quite. I mean, there was a pulse, of course, and the power. because of the duration, there probably wasn't enough power to cook you. But having said that, we did have annually, we'd have
checkups.
Checkups, because we were working with these radars all the time, and it could have made us sterile and all sorts of things that we'd actually have to have. I can't actually remember how the tests actually went, but I know we did them every year.
Blimey.
You were told to, put your hand in front of anything that you're particularly attached to while working near a radar, because that was the workplace health and safety standards we had, I think, at the time, wasn't it?
They provide you with a cricketing box or something like that with
a bit of foil.
Anyway.
We needed a cricketing Faraday cage.
Faraday cage, yeah. And in your case, John, I won't go into size, but yeah, I understood. You have to cover a certain area.
A large
Maybe
cage?
that's why I didn't get one.
How obvious of me. That's right. You didn't need one. Okay. So what was the storm event that sort of created that catalyst for us meeting? Pardon the obvious pun. Anyway, sorry.
It's a good question, because I try to think about it and I can't remember the exact details, but I think it was over in Sydney, and I'd on the side I'd started a company, thinking that would be my way out of working for anybody else, called Music Labs.
I remember it well, John. I remember that part well, exceptionally well.
And our very first product came out in 1990, which was probably at the time a world-class D-to-A converter using Burr Brown 20-bit ladder DACs, which were the bee's knees at the time. We'd also used the best digital filter that came out of Japan, a company called NTC. And we did some funny, or not some funny, but we did some advanced things that people didn't do at the time. We had really good anti-jitter circuitry.
She's ahead of your time.
Yeah, it was pretty. We just didn't use a crystal, which is what all the DACs that came out at the time were using. We actually developed our own sort of PLL circuit and got the jitter right down. Not that it's as critical as it is now with the Sigma Delta DACs, run at much higher clock frequencies and far more susceptible to jitter issues. And we also did something that I've never seen before or since, and that is that the I2S, I'm sorry to get a bit technical, the four data line, or the four signals that need to go from the digital filter to the DACs, we actually opto-coupled. So there was actually no electrical connection between all of the digital stuff that came in, the SPDIF, and the digital filter, and the analog output circuitry. So that was something that really just reduced the noise floor, and any digital noise just completely eliminated.
Just to throw my two bobs worth in, we heard that, I'm not sure when you left the music labs with us, I think, with Ket Knight Orpheus, and it was gobsmackingly good. It was an amazing DAC.
Yeah, and God,
beautiful sounding.
Yeah, and God bless the great Peter Stein from ME Sound, but he liked it so much and rebadged it for a while.
Oh, is that right?
Sold it under the ME brand, which is, I think, how we all got together in Sydney.
I think so too. Yeah, you're right.
Peter Stein, he introduced me to you, Brad, and your lovely Orpheus speakers at the time.
Yeah.
And then there was me. I don't know if there was anyone else, but I just I can't remember it all that well.
Yeah.
No, it's the drugs.
Yeah. Yeah. Peter Stein was a gem.
Yeah, absolutely.
Well, actually,
very sad.
It's I mean, he
that he's no longer with us.
Well, and he was a super smart cookie, probably as smart as yourself, John. And and I'm being slightly facetious. I have no idea who's the smartest.
I think he's a bit smarter.
But well, he did sell a hell of a lot of amplifiers, but the biggest difference between, and this is not being unkind towards Peter, because the thing is, manufacturing has moved on, of course, processes and capabilities and what have you. He was building amps at a time when CNC was in its obviously very early stages and was no doubt expensive. But the difference in fit and finish and the appearance of the casework of your two products, and I know they're 20 years apart or 30 years apart, so not to be compared, but it's something that I don't want to go on about it, but the aesthetics have got to be right if you're going to sell high quality, relatively expensive products worldwide, and that's where Peter didn't quite get the ME up to that standard, I think, although the standards at the time were much different to what they are now. But I mean, his amps sounded fantastic, and actually were very reliable as well. But they weren't pretty, and your product is. So I just wanted to say that. I mean, it sounds kind of pathetic in a way, but it's an important piece of the puzzle. And if you consider some of the utter rubbish that sells that everyone loves, it's partly because it just looks amazing. They've spent most of the money on CNC. Have you got some thoughts on that, John, at all? I know we're jumping away from the history lesson a little bit, but I mean, it seems that your product is as high-tech and as thoughtful inside as outside, but you've got to have both, and you've got both. And as you said, you didn't originally have that until your fortuitous CNC friends, they're getting together with him. Yeah,
exactly. Yeah, we, look, I'm a good designer and a good builder, but I'm not great when it comes to aesthetics. But we did have, the longest COVID lockdowns in Victoria.
Yes, you did.
In the world. And so that gave me a lot of time to kind of think about the new designs. And I just wanted to create something that was going to, have so much eye candy, but be classy.
Yeah.
Would just interest people, because there are just, there's no time in the history of the world where there is, so many components available now. There's so many choices.
Yeah. And
you really need to kind of stand out from the crowd if you want to at least get someone, to pique their interest. And I thought I just can't do another plain front panel. So we got some custom made meters. And look, for the most part, unless someone's got, which no one does, perfectly 8 ohm speakers, flat speakers across the audio band, that they really are just cosmetic, and they're, just something, just a bit of bling, but
it's great. It's great bling. It's very good bling.
Yeah, but it is. It is good, and I think it really works with the proportions that we've chosen, and it's just it sells ridiculously inexpensively, really, considering how much work goes into just the chassis. But I have had people say, that looks like a 40k amp, John, and that's the best compliment that I could ever ask for.
Yeah, and I would concur. And just on that subject of the chassis, so the front panel is beautifully CNC machined, obviously solid piece of aluminium, and beautifully finished off and inscribed, and of course you've got those beautiful VU meters, etc. But what all very beautifully executed aesthetically, but the chassis is then a solid chunk of alley that's all machined out, or is it pieces screwed together? Or please explain, what.
Yeah. So they're all pieces that are joined together.
Yeah.
So the front panel of the power amp is 16 millimeters in thickness.
Yeah.
The two side panels, which are machined into heat sinks, that straddle the whole length. They're actually billets of 50 millimeter aluminium.
Wow,
so there's a lot of aluminium, a lot of weight.
Yep.
And top and bottom panels are a quarter inch.
Mm-hmm.
6.35. Yeah, quarter inch. Yeah, 6.35. They're quarter inch machined. So the front panel actually it dowels into the side heat sinks.
Okay.
So it locks it in and lines everything up, so it's just, like millimetre perfect.
Yep.
And then
hundredths
they're
of a
screwed.
millimetre perfect, I would guess.
Well, actually, 100, yeah, probably 100th, yeah, exactly.
Yeah.
And then they're screwed as well from the inside.
Okay.
To anchor the front panel onto the heat sinks. And then the top panel has 10 screws that screw in into the heat sinks and the front panel, and the rear panel, and the same with the bottom panel.
And all of that sounds a little bit like a Meccano set, except when you see it assembled and finished, it's anything but. It just looks it looks hewn from the solid, really, and it's just, I keep going on about it, but it's completely impressive. So we're going to have a quick break and come back and talk about two things. One, I know Brad's got a question about transistors, we're going to talk about what's inside the amplifiers and touch on the preamp briefly. We're going to talk about all important power supplies. Everyone's concerned about power supplies these days, and also just finish off that Music Lab story of sort of how you got started in the because I just sort of jumped away from that, which I shouldn't have. We should have finished that story, but
the Music Labs one is a good one. I think,
the Music Labs and the what's inside, and also tell us about the preamp and the power supply. So 4 things really. So thank you folks for listening this far. We're just going to get into the good stuff now, and we'll be back in a second with Jon De Sensi from OAD Labs. OAD Ultrafidelity, in fact, and of course Brad from Serhan Swift. Hey, thank you for listening to the Not an Audiophile podcast. It's very much appreciated. We'd love your feedback. Like, follow, comment, share, all of that sort of stuff. Certainly comments on YouTube. We're on YouTube. Fire away. Tell us what you think, and we may even answer you back. Thanks again for listening. This was the ad break. Back to the show. Hello, folks. We're back, segment 2 of Not an Audiophile with Jon De Sensi and Brad Serhan assisting. Myself, Andrew Hutchison. Now, it's a great conversation because this amplifier, or amplifiers, because there's a phono amp, a phono preamp, a normal line preamp, and a power amp in Jon's range, OAD Ultrafidelity, and we were discussing how carefully machined and how world-class the product looks, and we're about to discuss the insides. But before we do that, Jon, I'm just interested to know how you said you hooked up with a guy who was into CNC and also had a love of audio, so it's sort of a match made in heaven that you're good friends. But just how good is their machining, and what else does this company do that, is it a big business? The business is huge. It's Melbourne based. It's still owned by a family business. It started in 1974. Okay. And they literally make the best grinding machines and CNC systems on the planet. Okay. On the planet, that's a bold claim, but let me guess, you've got a trinket of information that might back that up.
Well, look, I know that lots of countries have tried to copy or tried to equal what they're doing, and they haven't succeeded to the point where, like even in just prior to the iPhone release, of course, the very first iPhone, Apple or Foxconn, who build the Apple iPhone, actually could not build their particular case, their metal cases, metal chassis, without anchor tooling, and so they received a very large sum of money to provide tooling to build. Anchor
Tooling being the company you use for your CNC work.
Correct, same company. Yeah.
So what were they making for Foxconn that make the iPhone?
Well, they were making all of the little, I guess, tools that enable you to shape aluminium to make the iPhone case, essentially.
Wow. Okay. So let me get this straight.
To the precision that it needed to be.
So that it just clips on so perfectly to the chassis. So let me get this straight. So Apple, who obviously subcontract the construction of their phones out to this Chinese conglomerate Foxconn. Foxconn comes to a Melbourne company that you use for your own amplifier construction because they are the best in the world and the only company that can actually make this thing to the precision that is required for an Apple iPhone.
Correct.
Wow. Okay.
Correct.
That's something.
That's the verified story.
Wow.
And they've got a massive research and development arm, which keeps them, a few steps ahead of their competition, and they literally are a market leader in what they do.
Wow. Okay. And
that's amazing.
It is amazing, and it's almost like sometimes you say, we don't do anything in Australia anymore. There's no manufacturing, blah blah blah. Well, actually, there kind of is. I can think of a few others as well, but that's quite something. And so, do they do other, super high tech, high precision stuff for other overseas concerns?
Look, most
that you're
probably.
Aware of? Yep.
But not that I'm aware of. I haven't really taken a good. They keep a lot of it to their, close to their chest.
Okay. Yeah.
As they would. But this is one story that I've heard, time and time again from family members. It's still a family-owned company, and from employees.
They must be pretty proud of that. And but so really, when I glanced across, saw your product for the first time, I thought, wow, that is something. Then I wasn't mistaken then. So it just happens that perhaps the best CNC machining company in the world did the work. So that would help to explain that incredible fit and finish. Thanks for that. So let's take the lid off now and move inside. So you have this history of modifying Sansui amplifiers, and then not suddenly at all. Clearly, your knowledge, you've tried all sorts of things, and we're going to round up some of that history in a second. But skipping forward nearly 30 years, you've obviously honed the development of the amplification circuit as well. And was there a refinement to get to this final design in the super casework? Was this a new or tweaked design or clean sheet of paper, or was it actually just a development of something you'd been doing for 10 or 15 years?
It was a development that of continual improvement over the last 30 years.
Okay, wow.
Essentially.
30 years.
So
okay.
Our amplifier is unique in that just about every and I still do a lot of high-end servicing of amplifiers, which I'd prefer not to do. But
we all would prefer not to do it.
Yeah. Unfortunately, there's it's going the way of the dodo. Those sort of people that can service high-end audio gear. But virtually every amplifier I've seen uses like common emitter output stage amplification. I've never done that, including with the music labs as well as the OAD. So we flip the transistors around.
Oh, rightio.
And so rather than, there is a little expense to be paid, which is a little bit, slightly higher output impedance, but it's not a big deal. And damping factor certainly isn't an issue. And the reason for that is you just get a more linear output stage. A diode is a non-linear junction, and whilst you can buy common emitter amplifiers, so they're fairly linear, they're never going to be quite as linear as flipping the transistor around and using it as an amplifier, which is what the transistors were originally intended for.
Okay, so you've got collector resistors instead of emitter resistors. Is that is that how it works?
Yeah.
Okay.
Yeah.
That's
Well, we do have them in the collectors as well, but that's just to balance all the currents between the output transistors as well. Make sure they're all getting an even amount of current, and not just relying on a production run of the internal resistance of the base emitter junction.
Yeah. So sorry, yeah. So you may have meant to say emitter. So you got both emitter and collector resistors.
Emitter and collector.
Yeah. Okay. Yeah.
But our collectors go through a 0.1 ohm resistor to the output.
Whereas
binding post terminal.
Because obviously the emitter resistor is a few ohms or whatever it is, 10 ohms or something. I don't know what.
Actually, it's only 0.1.
Oh, it's tiny as well. Okay,
it's the same.
Yeah.
Yeah.
So that's okay. So completely different configuration, but bipolar transistors, no MOSFETs here. Is that's which is fine.
Yeah.
But
there's been a lot of debate that people in the know would know about over the last 40 years. People like Douglas Self from the UK and Edward M. Cherry from Melbourne University, who's a very fine amplifier designer. I've had lots of debates through Wireless World and other magazines about which is better. And I'm with Douglas Self and believe that and have tested that a bipolar transistor is actually more linear than a MOSFET. And you don't have the high, input capacitance that audio MOSFETs tend to have. So I think overall they're just a better choice these days.
Well, I feel like bipolar transistors have moved forwards with many iterations over the last 30 years, and MOSFETs are sort of, well, for audio amplifier outputs, I mean, there's plenty of MOSFETs, right? I mean, as far as for controlling motors or something, but for audio, they haven't been flavour of the month for a good while, have they?
No, they haven't, and they're actually almost impossible to find now. Like since Toshiba and Hitachi, Toshiba no longer own their semiconductor division, that's been sold off, and they don't make them.
Okay.
And Hitachi before that stopped, years earlier.
Oh, that's right. It was Hitachi were those early ones. The type
back
numbers,
in the 80s.
I forget. Yeah, but the 80s ones when MOSFET amps were the go for quite a few years, really. I mean, they were. And I mean, was there more to it then? Was there? I mean, they've got quite a charming sort of sound, but they always feel like they're a bit doughy sounding compared with a bipolar transistor. Is that your thought, or what's? I mean,
yeah. Actually, I repaired an amplifier. I think it was a Plinius actually, from 1987, about a year ago.
Yeah.
I set it down in the system, and it was a really, really pleasant sound. It was actually really quite warm.
Yeah.
It did sound more like a tube amp, but it just lacked complete detail and detail compared to what I'm getting out of my amps.
Well, yeah, which is obviously at a fairly heightened level, but
and look, they're 30 years apart as well, and I'm using state-of-the-art components, and they're using state-of-the-art back in 1987, and things have moved along.
Yeah.
But yeah, it was quite a different sound, and if you like that sort of sound, if you're not after an accurate sound, and look, there is no right or wrong. It's just whatever people,
whatever they're attracted to. Absolutely.
Attracted to, yeah. But I listen to a lot of live music, and so I tend to try and make amplifiers that mimic that. I mean, it was really lovely to have it here for a few days until the customer picked it up because it was just so different, and I could see the attraction towards it, but then I could also hear exactly the differences between bipolars and transistors that I've had experimented with over the last sort of 40 years as well.
Yeah. So
and look, you're quite correct about the bipolars. They've come a long way in recent years. There's a development of a new transistor for audio called a thermal track.
Okay.
Which actually has 5 pins. So
those things. Yes.
Yeah. So they've embedded a diode, which is electrically isolated but thermally not. And they've taken bipolars to a completely new level, which is what we use.
Oh, you do use those? Okay. Yeah, actually,
for
some reason I thought those 5-pin devices had faded from popularity, but I'm probably thinking of an earlier one.
There were others.
Yeah, but yours, okay, so you're using those devices, which I have seen in some pretty fancy amplification. Now, Brad's got a question that he wants to ask, I believe. Brad's phoning in from Sydney. Hello, Brad.
Hello again, Andrew.
Something about classes. You're very concerned with class.
Well, I'm not the sort of class we might think about in society necessarily.
Well,
but
it's Australia,
more about
there is no class.
Yeah, we're egalitarian, supposedly.
Indeed.
Well, I just do speaker design, and my memory from my electrical engineering years is poor. So explaining the sort of, some people extol the virtues of sort of running a fair bit of Class A power, but I asked John the other day about this, and he explained to me how he works it with Class A or Class AB, and if you remember my question, John, you might be better to ask the question of yourself and then explain it. I played soccer this morning. I'm a bit tired, so there you go. That's my excuse.
Yeah, that's right.
Oh.
Well, I mean, I guess the word has it that your amplifier, John, is biased heavily into Class A and delivers a decent, useful amount of power with zero crossover distortion. Is that the case?
Well, almost.
Okay.
Well, considering that the relative to the power output that the power amp can put out, then it's not heavily biased into Class A, but it is from another point of view in that, despite what most people believe, most people are listening between sort of 5 and 10 watts of sort of average power going into their loudspeakers.
Yep.
Even with, just under 90 dB SPL speakers, most people are not really getting hundreds of watts into their speakers, despite the fact that they think that they need an amplifier that powerful.
Well,
what we do is
you make them.
Yeah,
it's
that's
your
right.
fault.
Well, I keep getting asked to make more powerful ones.
Oh, do you really?
Because there's not because of they're going to sound better. It's just because there's an arms race out there, and people think the more powerful an amplifier is, the better it's going to be, or the more impressive it is, and they're willing to pass over their money.
But
you look at another fine Australian company, Halcro,
yes,
who make a £40,000, which is close to $100,000 Australian power amp, and their power output is 180 watts per channel, the same as what we make.
I was going to say yours is about 180.
Yeah, and that's a sweet spot. It's a real sweet spot between reliability, using the fewest number of transistors, which will always sound better than using more transistors and trying to bias them up and having the parasitic oscillations that you might get, and there's all sorts of other complications.
So how many devices per rail are you using per channel?
So in each channel, there's 2 devices per rail.
Okay.
So four transistors per channel. Yeah.
So that's I guess that's quite typical, and that's a good balance between power output and not having extra devices, which just complicates things and muddies things up, I guess, and obviously, and complicates things as far as the circuit. So that's 180 is the sweet spot we were talking about. So what do you think then you've got? What's the power output in true Class A then of your amplifier?
So we bias them to about 10 watts of Class A. Yeah. So for most people, they'd be listening into Class A. But even beyond that, it's not really an issue if you're using these thermal track transistors, because one of the things that they do by having the diode built in is that you can get massively increased settling time and bias stabilization in the output stage, and what happens is that you tend to get, even in Class AB, and I've measured this with an audio precision, you will get Class A type distortion figures out of a Class AB
using those
the thermal track transistors.
devices. Yeah, okay.
and using the thermally integrated bias diodes. Yeah.
So that's a key part of your design. Is those particular devices, output devices. Is there any other? I mean, I know there's other tricks, but what are the other handful of key things that you feel strongly about? I mean, you clearly feel strongly about a fairly simple output stage. What about power supply? I mean, we mentioned Peter Stein. He was a lover of paralleled up smaller value electrodes rather than two giant whopping bucket-sized ones. What do you have thoughts on that at all?
I do. I mean, every audio amplifier, what it's effectively doing is modulating the power supply voltages. Mm-hmm. So the better and the cleaner and the more ideal the power supply is, then you've got more of a chance, provided your audio amplifier is a good design, to give you the best type of sound. So we currently in the Vajra we do use just a conventional toroid. It's almost 1 kilowatt, wow. Which is grossly overrated.
It's a hefty transformer,
for a 180 watt per channel amp. But then we use. I know we were the very first, and we may still be the only company. And the reason why we can do this is because we're very small, I guess, and we can change things very quickly. So what happens is some clever people in the UK years ago worked out that you get eddy currents that circulate in the foil of an electrolytic capacitor in audio use. So they come up with this clever idea of actually putting a slit in the foil so that it would break that circulating current.
Yes.
And they swore black and blue that you get better mid-range and better top end.
Yeah.
Because you don't have that eddy current sort of modulating the DC that's there.
Sure.
So it all makes sense. But unfortunately, they went on to make capacitors that weren't high enough voltage to be used in big powered amplifiers.
Oh, okay.
And then a couple of years ago, a giant American company started making 80 volt and 100 volt electrolytics with the slip foil technology.
Oh, okay.
In the EU, and so we quickly switched to those from our old models to the new models because they came out as we were just building.
Yep.
The first set, and I think they've made a massive improvement. They're also, a lot bigger than what we've used in our older models, so that the DC's stabilised even better. Yeah.
So just one big capacitor for each rail, or have you got a few ganged up?
No, there's a few ganged up. So Peter Stein was correct, and in the music labs we used a whole lot of very small ones as well.
Yeah. Okay.
And the idea of that is that smaller caps are faster than bigger caps. Also, smaller caps in parallel reduce the output impedance, and they've got a lower output impedance to begin with because they're smaller than a big cap. Lower output impedance just starts to emulate more of an ideal power supply. In the Vajra, we use 12 of these slip foil caps. So 6
so quite an array.
per rail.
Yeah, all right. Yeah.
Yeah, and they're I think they're 6,800. No, they're 10,000 mic each. So that's
okay. So tons of
60,000. Per side. Yeah, a lot of capacitance. And
is that a stereo power supply or a mono effect? I mean, that's the wrong terminology to use, but
no, you're right. The power supply is shared between the two. So
okay.
It's not a true mono internally. No.
Do you feel that that's? I mean, there's some brands that are big on that, and others could care less. Have you? I mean, you're saying the power supply is an integral part of the signal, so we got some slight monoing effect because we haven't got a separate, AC/DC power supply section, or is it? You think it's negligible?
Look, it's really interesting. I used to have people ask me, or probably still do actually, saying, when are you going to bring out monos?
Yep.
And I'd often say, come over and we'll bring out two stereos, just play one channel, and then they'd take them home as well. And we're all in consensus that actually every time we just ran the stereo amp as a stereo amp and not run it as a mono and have two of them, just sounded better every time. And I still don't know why that's the case.
Yeah, that's odd, isn't it?
But they said that with the monos, you tend to get, if you've got demanding speakers, you might get a little bit better, the bass extension. But as far as the rest of it was concerned, like the musicality and the mid-range, critical mid-range sort of frequencies, everyone, including myself, we always preferred the stereo amp.
Well, that's a very interesting observation. So, I mean, you would think maybe using two amps and using half of each one for each left and right, one for left, one for right speaker, and then obviously there'd be a bit more power supply for each channel, effectively, if it was required, and that it couldn't sound worse, but it may not sound much. It may not sound much better, but it can't sound less good, surely. And yet that's the thought. That's almost bias, sort of. In reverse, in the sense of you'd set yourself up for it to be better and you convince yourself it was, but in reality, no, not in this. And so both various clients or associates that have tried that and yourself all agree that the just one stereo amp sounds better than two monos, which of course would be better than two mono blocks for that matter.
Yeah. That's exactly what we all found.
Yeah,
now, I don't know whether that's just with my amps, because I haven't tried it with any other amp. But I think part of the reason why I think it does sound better is with the monos, the sound in the middle just seems to it seems to disappear a bit. Whereas with the stereo, probably because the two channels are sharing the same power supply and there's a little bit of crossover, it fills the middle, and so you've got this seamless wall of sound from left to right, and that's why I prefer it and why they preferred it as well.
Yeah, that's interesting. So
whereas the monos, it just sounds like a dual mono recording off an LP or something, where you can hear great sound in both channels, but it just doesn't.
So it's a thing. It's not so much detail in the mid range; it's just the way the stereo gels. Is that the thing?
Yeah,
okay.
I think that's what I was noticing.
Yeah, okay,
absolutely, absolutely,
very interesting.
I still don't completely understand it, but that's what I'm hearing. Yeah.
Okay. Right.
Yeah.
Well, moving on. So, input stage to the power amp is traditional, or have you got some interesting differential pair arrangements or something? Or
we probably do something. Not a different arrangement. It's a fairly standard differential pair, but unlike again most amplifiers that I've seen over the last 30, 40 years, the Japanese were doing this really well back in the old days, but again, now that Toshiba's not making audio transistors, you can't get really good pairs anymore. But we do use a super matched bipolar input differential pair. So they're actually on the same substrate and they're thermally matched.
Oh, okay.
And the idea for that is that we didn't want to use a DC servo loop, and we wanted to obviously minimise any DC because our amps are DC coupled, so they're literally 0 to 200k.
So they're
or something.
DC coupled, so you need extra, you need good thermal stability, I would imagine, and to keep that DC voltage to close to 0 as possible. And so I didn't even realise they were still making input pairs,
super matched pairs.
Yeah, that's a thing. Still comes in one package with 5 legs? Is that or is it not like the old ones?
6 legs, yeah.
Oh, 6 legs.
Yeah.
Okay.
Yeah.
Right.
Well, 2 basses, 2 emitters, 2 collectors.
Not common. I don't know, what was the common one on the 5-pin ones? I can't even remember. I mean, hey, I'm just a technician.
Okay. Oh, you're talking about one that had the bases joined.
The 2SA798 or whatever that had bases on
yes,
one
my
pin or
apologies.
whatever,
My apologies.
Yeah, but yours. So the ones you've got are literally two transistors on the same substrate in the same plastic moulding, 6 legs hanging out the bottom of it.
Which are absolutely identical. Now, there's still a lot of those sort of transistors made, but they're not audio quality, as in they're noisy.
Oh, okay, yeah.
And they're made for companies that might be using them for different non-audio applications. But there is a company, thankfully, in the US, in California, called Linear Systems.
Yeah. And
they make a whole range of very high quality bipolars and FETs.
Okay.
And they also get their hands on obsolete equipment, like from Toshiba, and they remake transistors audio transistors that were once incredible, and they actually make them better. I don't know how or why, but they actually make them to a higher spec. So thankfully, there are companies like that have seen a little niche in the market.
It's just amazing. You're what else is amazing is that it feels like there's a lifetime of work and research to find all of these suppliers, because it's not like you're putting an order in with DigiKey by the sound of it, or let alone going down to JCar to pick up some.
No. It's look. I'm on so many different. I'm on so many different newsletters for components.
No doubt, yeah.
And there's probably lots that I miss out on. That
don't say that. Don't admit to that. You're on top of it. You've got the best of everything.
But yeah, I do seem to come across the right component at the right time, and it all works as a synergy, and I'm really excited about the sound. That we get out of our amplifiers.
Yeah. Well, the preamp. Okay, without a preamp, we can't. We'd have to listen to it flat out the whole time and only have one input. So what's going on in the preamp? That's. I think I would guess that the volume control is probably the key engineering tour de force there.
It is. The preamp our earlier version had a touch screen, which was actually, from a practical point of view, I think a lot nicer to use and a lot more flexible. But when we redesigned the preamp, we thought we'd go to a more conventional looking preamp and something that you could look at in 25 years or 30 years and say, wow, that's a classic. It still looks really good on the eyes, and it's not going to date. And anyone who's been to the website, might have that opinion. But yes, you're right. The volume control is really quite sophisticated. And in fact, in many ways, the preamp electronics is more expensive to manufacture than the power amp.
Is that right? Okay.
And the reason being is it uses a dual shaft stepper motor. So it's got the shaft out the front, where the volume knob is actually mounted, but it has a shaft out the back. And so people are probably aware of the term fly-by-wire. So modern cars don't have a steering column that goes all the way down to the wheels anymore.
On that front, fly-by-wire throttle we know about. There's no throttle cable operating a carburetor, or for that matter, the intake. The throttle bodies, right? So the steering by wire thing, which aircraft have been like that for a long time, I guess. But I think Airbus started that. But the new, that stupid looking Elon invention, the
Tesla.
But specifically
Cybertruck.
The Cybertruck, yes, the Cybertruck. What a wonder it is. Biggest step back in automotive design ever. But on the other hand, it has steering by wire, which I didn't know would even be legal. So there's other cars that have that as well. I have a vague feeling a Volvo had it as well, but What?
I
I don't want to go sideways, but there's a few that have got it. Is that right?
I think you'll find probably every car made in the last 15 years, maybe even 20 years, is fly-by-wire now. In other words, they don't have that steering column that goes all the way down that mechanically turns the wheels. They actually have like a magnet that, in fact, they'll have several of these for redundancy, of course.
Yeah.
Because if one of them fails, you're going to lose your steering. But they literally, there's a magnet that actually turns in sync with the steering wheel.
Yeah.
It'll have a chip that is literally a millimeter of air gap away from a neodymium magnet.
Yeah.
And it actually will actually read the rotation incredibly accurately, like, below 0.1 of a degree. They can do.
Yeah.
Not that you'd need that for a car. And then that feeds up to a microprocessor. Microprocessor then actually controls a motor that actually turns the wheels, believe it or not.
Yeah, okay. No, I wasn't aware of that, and I have some interest in cars, but I also suspect that maybe there's some mechanical redundancy there, and the difference with the Tesla is that it's just not connected in any way. If the battery goes flat, you crash. Maybe not quite like that. The battery's not going flat anyhow. It's got plenty of battery power. But yeah, okay, so your volume control uses this technology. So it's coupled, but it's mechanically decoupled. Is that the point?
Yeah, look, this is all just so that someone can control a knob for the volume if they're going to be walking up to the preamp.
Rather than just use the remote.
It's not actually needed for the remote, but
of
course when you use the remote, you want to see the knob turn because otherwise they won't match what you're actually... what volume you're actually at.
Yes.
So it was a lot of work. It was 2 years in development. There's literally over 20,000 lines of code.
Oh wow.
Written to, and it's just simply for to show you, and of course you can control the volume from the front panel volume knob, and there's a whole lot of 3D printed plastic that actually mounts to the rear of the stepper motor, which holds the magnet in place and holds a circuit board that has the chip that actually senses the rotation. And that feeds that all back to a microprocessor. And once the microprocessor knows exactly where the volume knob is rotated to, it actually then feeds a signal out that goes to literally, right to the back panel, the rear panel, where there are two audiophile. I think they're the only. I'm pretty sure they're the only audiophile grade R2R ladder volume chips on the planet. And there's a little story behind that. A few years ago, two Japanese employees begged their bosses to make an audiophile grade R2R ladder DAC because they were, sick of using relays and resistors. And so, in the size of about half a postage stamp, they made these little chips that are incredibly accurate. They're all laser trimmed resistors. They're all thermally, connected together. They also have a zero temperature coefficient, so they don't drift. And they are literally, transparent to the sound. They just they do their job, but they don't get in the way of the sound. The story is they also sent some to Nelson Pass, and Nelson Pass was so blown away with them that they ended up using them in only the top model Pass Labs preamps.
Is that right?
Of course, we're not talking about American preamps, so we'll get back to that.
No. Clearly, the best preamplifier in the world is made at your factory. We're not biased at all. Such an impressive story, though. So you've got the best attenuator chip on the planet, and that I guess that's controlled by a microprocessor that's also controlling all of this other stuff as far as making the knob turn and what have you. And obviously you've got input switching and commands coming in by remote, etc. Is there aspect to the circuit that obviously the little bit of buffering and amplification that's involved. Well, for that matter, how does the input switching happen? Is that little relays, or is it some other even better way to do it?
No, we are using high quality signal relays with silver contacts, and again they're right behind or alongside the RCA inputs, which are all PCB mounted.
Yep.
So we're just trying to keep the signal path as short as possible, and then the volume chips are right there as well. There's no buffering that's required. It goes through. The inputs get switched, and then whatever signal is switched goes through the volume control chip, and then the volume control chip then goes into our discrete op amp design. And we have 4 discrete op amps, 2 on a board, and one's for inverting and non-inverting. So this is a true balance that's not using any balance to single-ended to balanced chips that you find in a lot of high-end gear, as well as most tube amps, because you don't have like a P and an N version of a tube.
No, there's no balanced. There's nothing balanced in the tube world, is there? Just. Am I right or wrong on that?
Well, not as far as a tube, but you can use a transformer, of course. But of course, on one side of that transformer, it's going to be single-ended. So, so it's never going to be true balanced unless it's passive. Whereas in my design, it is literally true balanced all the way through.
Yeah. So So this is a serious piece of equipment.
4 discrete op amps.
So
and look, and they're removable. They're plug-in, so you can actually replace them with better, models down the track, if that ever comes to be.
So I feel like the piece of the puzzle that we're probably ignoring, having had you brief us on the fact that this thing is there's an incredible amount of thought's gone into it, and it's clearly world class both on the inside and the outside. How do you sell them? I guess they're sold around the world or in certain other countries other than here. But what sort of ballpark money are we talking? Because they're not supersonically expensive, are they? As my memory serves me correctly.
No. So we
less than the price of a Concorde is what I'm implying. Well, I mean, I'll let you speak, but I don't know how you sell them, and I want to hear about that, because ultimately that's what you make them for, I guess, is to other than it's not just for your own amusement.
No.
Although at times it may feel like that, but
absolutely.
But so how do they sell and ballpark money, sir?
Yeah, so the recommended retail for the Padma is 10,000 Australian dollars.
What?
And
for the preamp.
For the preamp.
So 10 grand. Hang on.
Yep.
So it's got all of the stuff that we just discussed, the best of this, the best of that, the best machining, the best for 10 grand.
Yep.
Okay, so why does anybody buy anything else? That's amazingly good value. All right, and what about the power amp?
And the power amp is $15,000 retail. Yeah,
You got to be joking.
Even more.
So the guy who said it's worth 40 grand, I take it. Well, he should have bought one, shouldn't he? $15,000. That's
look.
amazing.
If it was made by any other high end company, the combination would probably be around that sort of 40-50K.
At least.
They're very they're incredibly inexpensive.
Incredible value.
Incredible value.
Does that okay? So
and
then, sorry, Brad, where you go?
Oh no, maybe it's not the right time to mention this, but I'm using John's previous model power amp.
Yeah.
He loaned it to me just 6 months ago, and
did you send him an email saying I'd like some cheap equipment, please? And John.
No, I did. I don't communicate by email, so I'm highly. Although I'm not verbose in this podcast, I spoke to John at length.
Okay.
he just gave up after a while. No, I just he told me there was the a pre-loved, if that's the right term, power amp.
Okay.
And he kindly loaned it to me.
Mm.
And the only reason I'm throwing that in is that I've had Gary Morrison's wonderful pure audio amps and been very loved his amp and still love his amps. But sadly, Gary's passed away, and dear man. And John's amps is a joy to listen to, but not only to listen to, but it's also, I've designed a couple of pairs of speakers using his amp just for the past 6 months.
Okay.
So it's been a great designer's tool, if you like. But
Okay.
Perhaps I'm a tool mentioning it but anyway, it is gobsmackingly good.
Yeah. Okay. I mean, I have heard it, but not properly, because I think.
Well, we were lucky enough to have it.
In a 5-second listen to the show is not really listening.
We were lucky enough last year at the Stereo Melbourne show to share. Well, there were 2 rooms. John was in 2 rooms. He was straddling both rooms, and we had his pre-power combination with our speakers. So we got to listen to it firsthand. So both Morris, myself, and Les Davis as well, we were just gobsmacked at the quality of it. So yeah. Anyway, I that's a little hometown bias, but he wonderful amp.
Yeah.
Okay. Really.
Well, I mean, I'd probably buy it at that money based on the just the level of high level of engineering that's gone into it. So
involved.
So does that mean, John, that very sharp pricing that you offer these 2 pieces for means you're selling them direct primarily? Does it, or is
Yeah. So I'm essentially selling them direct at wholesale prices, essentially, because I just want Australians to have access to this, locally made and I think obviously biased, excellent equipment. So my issue is, 9 times out of 10 people that come into our showroom, walk out with amps or something.
Yes.
It's just getting those bodies through. I have tried a lot of retailers, but there's a lot of issues with retailers in Australia. Most of them import their own gear and have their own vested interests. Our brand isn't that well known, so which is just justifiable. And so there's a lot of retailers that just want brand names that people are going to knock their doors down to come and buy.
Yeah.
I'm battling all of those issues.
It's a podcast in itself.
Yes, it is.
It's a series of podcasts. Is the difficulties of do you make your product a little bit more expensive because you're effectively subcontracting out the retailing of it rather than doing it yourself and getting the advantages of that as far as it's having it sit in front of more people, but then you walk into your average, professional, good retailer these days, and there is so many products in there. You got to work out how does your own stand out, and I don't know. I don't even want to. I don't want to go there. I've many thoughts, and I'd have to take some notes for myself just to remember. It's just such a complicated puzzle. It is easier to sell it yourself, John, as you know. You just offer them for sale, do your own demos, but then the problem is, do people, you're missing 95% of the buying public straight away. That's the catch. That's as far as because they're not walking into your showroom, they're walking into, like I said, 95% of HiFi traffic is walking, of course, into a HiFi showroom, where they're not talking about your product. I guess that's why we've got you here today. For me, though, it's a bit more selfish than that. I just think it's the most impressive Australian-made hi-fi product ever. Bold claim, but and Brad, don't take that personally. And I don't, and I say that not because it's the best sounding amplifier that's ever been made. It's just but it may well be, but it's the most complete product. The fact that you've got all of those other things right. There's 3 aspects to an amplifier, I reckon. It's the way it sounds, is the way how well it's made and how reliable it is, but then it's how pretty it looks. And to get all 3 right, I think, is incredibly hard. And you've done a fantastic job of that, John.
Well, John straddles all three or four of those, all four. So,
well, industrial design, John, was your own work in COVID time, or have you got a mate who's a guru at drawing lines on a piece of paper or something?
I'm good at drawing lines with a pencil.
Okay.
Analog, mate. Very analog of you.
Yeah,
that's good.
Exactly. Yeah. I'm still an analog fan. So we did that, but then my very good friend now, who approached me about the remote control initially, wanted to buy my equipment but couldn't afford to. He's the machinist, the CNC machinist. Well, he's a CAD master, so he drew it all up.
Yep. Okay.
On CAD master.
Yep. Yeah, exactly.
It sort of reminds me of the story of. Sorry, it does remind me of the story. It was sort of not quite, but it sort of reminds me of the bloke that sort of liked the Rodson razor so much that he bought the company. And your mate, who I do know, who sort of approached you about doing the chassis for you, sort of in a sense got himself an amplifier very cleverly. I love it. It's a great story. Yeah. The fact that you use analog or pencil to scribe initially the drawings draws me on to the word analog in terms of your phono preamp.
Yeah.
I should not only let Andrew do that, so I'll hand it back to Andrew.
All I'm going to do is hand it back to me, and we'll have a quick break, and we'll come back and wrap up with discussion of both John's history with Music Lab and onwards, which we'll cover briefly, and the phono stage. And then on that that will be the Jon De Sensi story for this round. But I think there's a very good chance we'll have John back at some future show to discuss a couple of things that we simply won't have time to cover today. But without any further ado, we'll nick off, quick ad break, and we'll be back very shortly. Thanks, guys. Hey, thank you for listening to the Not an Audiophile podcast. It's very much appreciated. We'd love your feedback. Like, follow, comment, share, all of that sort of stuff. Certainly comments on YouTube. We're on YouTube. Fire away. Tell us what you think, and we may even answer you back. Thanks again for listening. This was the ad break. Back to the show. Hi, folks. Not an Audiophile podcast. Today has been an incredible tale of local manufacturing at a very high level from Jon De Sensi from OAD Ultrafidelity, and of course Brad is here as well from Serhan Swift, giving us a hand and asking some probing questions. John, we all need to go. Life is short. We need to move on, but the listeners are thinking this particularly. But can we briefly talk about your Music Lab, just how that piece of the puzzle fits together, and just touch on your phono stage that Brad mentioned earlier?
Right. Well, I guess Music Labs was my first foray into, manufacturing audiophile quality products in Australia. Mm-hmm. Like I said, we started with a real bang, probably the best product, or certainly one of the best products I've ever made, which was the Music Labs DAC, which was way ahead of what most people were doing at the time. Yeah. Just in a comparative point of view. And it probably would still be around today. It's just that at the time in the 90s, the majority of all of my distributors were actually in Asia.
Okay.
And then we had the Asian financial crisis.
Oh, and 97 was that? 97?
97. They all literally went under.
Yeah.
Because they were all being funded by the banks.
Yep.
And the banks wanted their money back. And so they all folded, and that meant, I had to start again. And it was also about the time where home theatre was starting to gather a lot of traction in the audio world, and people were more interested in multi-channel amps and.
Well, because DVD just kicked off.
Yeah, that's right. And so I thought I had another business opportunity, and thought maybe this has run its course, and so we we just let the company drift and
Yep.
close down eventually.
Put it into stasis, John. Put it into stasis.
Yeah.
Sci-fi terms. Yeah.
Yeah.
So
and then when we started OAD, OAD was not initially going to be electronics, manufacturing of amplifiers. It was going to be open baffle speakers, which is also a big passion of mine.
Sure.
And in fact, that's what the OAD stands for. Originally, anyway, open audio designs.
Okay.
To do with open baffles, but that became, being a perfectionist, that became a very expensive sort of way to start up again because of the way I wanted to do it about 15 years ago.
Mm-hmm.
And so we then just went back to doing electronics first, and then worked out a better way of doing the speakers later on, which weren't so expensive to manufacture.
Well, actually, I mean, open baffle, surely the easiest or simplest or least expensive loudspeaker to manufacture in a way, but you had something exotic in mind as far as the baffle. Is that right?
I did, yeah. If I thought about what I'm doing now, which is exactly what you said, it's the easiest, the most simple way of doing it. If I had done that, I would have started with the speakers.
Yeah, okay.
I was looking at a curved front panel, and I was looking at a non-rectangular front panel, and I don't know what I was thinking.
Well, you were trying to make it hard.
That's right. Yeah. Well, I thought that there were benefits, and there are benefits doing it that way.
Yeah.
You'd read Olson's book. That's what you'd done. The spherical way. There's no doubt.
That's right. So, and we contacted a lot of companies and got some CNC work, and it wasn't pretty when we saw the prices.
No.
And so retreated back to electronic amplification manufacturing until we worked out the simple way that everyone else does it.
Yeah. Which works. One thing, as open baffle speakers go, yours sounds startlingly good, and you seem to have gotten most of the benefits of open baffle and not too many of the negatives of that design arrangement. Moving sideways to the phono preamp. You've got because just a quick summary of what it is, just because it obviously fills out the range, and I guess it's important to note that your amplifier, your pre-power combo, is very much an analog amplifier. And so to keep that, to actually have an analog system, you would need a turntable or a tape deck, I guess. But turntable's probably easier to buy media for. So what's interesting about your phono stage?
So the phono stage was always going to happen, but I didn't know exactly how it was going to happen. And before I thought too much about it, I was actually contacted by Warwick Fremantle, who's a major distributor down here in Melbourne of very fine gear from overseas.
Mm-hmm.
I've known Warwick for about 30 odd years, and he asked me to make something that was sub $3,000 that was kind of world class.
Yeah.
And so we embarked on that path of achieving it. Luckily, Warwick brings in some of the best analog equipment, so we had access to a $100,000 Tech DAS with top of the range Lyra cartridge, which is probably a little bit of an overkill.
Yes.
For a sub $3,000 product.
Yeah, possibly. Still,
So we ended up, designing something that used 3 world-class op amps. One that's specifically made for moving coil, which does most of the gain, and then we wrap an RIAA around that, which is a partly passive, partly feedback sort of arrangement.
Yeah.
It's probably, and also because we were making these high quality CNC, all CNC panelled chassis for the preamp and power amp. We decided that we did the same thing with the phono, and which probably wasn't a great idea for a sub $3,000 product because it looks more like a $15,000 product.
Well, you could put the price
costs
up.
a lot of money. Well, that's the thing. We haven't put the price up in 8 years that we've been manufacturing them, and we probably should because my costs have gone up.
I think they might have gone up quite a lot.
To date, it is. Yeah, it has gone up quite a lot, and to date, it is still my best-selling product. So we do actually sell quite a lot in Australia, and we sell quite a lot overseas. So we've got a Singapore distributor. I've got an Indian distributor who's doing really well.
Yep.
I've got a Swiss distributor who's distributing it, over there. Yeah. So
impressive.
It's a great little product. It's ultra low noise. Very few phono amplifiers will have an 80 dB setting. So this thing you can go up in 5 dB steps from 40 or 60 dB up to 80 dB. It literally has a wide range of loading resistors that you can switch in and out to suit literally any cartridge on the planet.
Specifically, I'm guessing moving coil though.
No, it's moving coil and moving magnet.
Oh, is it really? It does both? Okay.
Yeah.
Wow.
Yeah. So it has a 40 dB, 60 dB switch where you can. If it's a standard moving magnet, you can go to 40 dB and step up from there if you want. Yeah. So, and it has input, and it has a range of 3 input capacitances. You could use them on moving coil, but they're more suitable for moving magnet for matching.
Yeah, that's flexibility.
So it'll match to any, well, like you say, you said it, any cartridge, moving magnet or moving coil on the planet, you can set it up to match perfectly. Do you have some kind of, this is not really a particularly technical question, but do you have some kind of chart that, suggested settings for particular cartridges, models of cartridge? Is that something, do you get feedback from clients or something on that, or like where does someone start, I guess, is other than looking up the manufacturer of the cartridge's suggestions, which I guess is a good place to start, but do you have any master
That's
plan?
a very good question. Very, very good question, Andrew. There are just so many different models that we don't provide a chart, but I actually am in the process of almost finished building a chart where someone can look at the data that came with their particular cartridge, and if they know how many microvolts or millivolts their cartridge is putting out, then it'll give you the optimum setting so that you can get like a fairly similar to a CD sort of output, 2 volts RMS.
Yeah. Okay. Yep.
But we do in our manual we do state that that we're happy to take phone calls. In fact, we encourage people to call us to find out what setting they require for their cartridge. So I do help people out almost sort of every fortnight, I would suspect.
It's an interesting thing. So you answer the phone?
I answer the phone, I answer emails, and give them that feedback and give them the settings. Yeah, absolutely.
That's old school levels of service right there. Okay, well, look, Jon, thank you so much for coming on today. It has been incredibly interesting. I've learnt a hell of a lot, and I'm going to guess that the audience has as well. Brad hasn't, because he knew it all already, but he's done a nice job of pretending. So I appreciate that. Look, thank you, Jon. Thank you so much. Good luck with it, and we will. You can supply us some information, photos, and what have you, and we'll put them up on the webpage for this podcast so that people can easily click through and find more information about your products. And the finer details that we haven't covered today due to lack of time. Although we've managed to make this the longest podcast ever, but it's also been possibly the most interesting. I mean, I shouldn't say that. All the other guests are like, it's
tremendous.
Yeah, but
Yes.
but I mean,
But without given our short-term memory loss,
that's the thing. It doesn't matter. Yeah, we're all. Yeah, that's right. So no, it's just so interesting and clearly very much cutting edge. It's always slightly odd that someone goes to so much trouble to build an exceptionally engineered amplifier, and ultimately it's for listening to music, not saving someone's life or whatever, which I'm not sure what I mean by that, except I do remember once, just to clarify that point, I did a tour of Name's facility in Salisbury in the UK, and it was just all these people in white coats. There's 100 people there or something walking around in white coats, just bending the laws of physics, all for the sake of amplifiers and CD players. And I'm just like, if you could just put this effort into curing cancer, it would make the world a better place. But that's I might edit that out. Actually, it's sort of I don't want to demean your efforts, John, and I'm not trying to suggest you move into medical electronics or what have you.
Oh no, Andrew, think about it, John. When you listed one of John's amps, or any of John's amps,
well, it's going to improve your health.
One tends to relax, so I think it's a health. There's some sort of health benefits.
And speaking of medical electronics, is that what Peter's business? Someone told me once that ME stood for medical electronics.
I thought it was modular. I think it's modular.
Yeah, that's much more.
But I have to check with.
Yeah, no, that's right. That's it. Yes, as the person who told me that was an idiot, like vast majority of people are. So I should. I think I might edit that out as well.
Andrew,
I might do an alternate ending to this show.
You're not a Mr. Trap, are you, mate? No, I didn't think so.
Let's re-end this, and I can edit the last
Andrew,
4 minutes.
Yeah,
sorry, keep going, John.
Know that we don't have white lab coats.
No, you don't. Okay.
I've heard that a lot of John's best work is done. No, I won't go there. So the other thing is, it's obviously I think we're setting it up, or I'm setting it up to say, or Andrew mentioned it earlier, we'd love to have you back, John, to discuss other topics, or maybe even one of our quick Q&As. And
yeah, I'd love to.
Well, yes, at some point in the near future, we will stop offering history lessons, which I find very interesting, and maybe not everyone does, and talk more about current issues in audio and what's important and what's not. So for that, we might indeed get you back, and also you can fill in some gaps and some of the technical aspects of your product, or any other aspect that you want to bring up. But thank you again, Jon De Sensi, for coming on from OAD Ultrafidelity, Melbourne manufacturers of exceptional quality amplifiers, and thank you again, Brad, for giving me a hand.
An honour and a pleasure, mate.
No worries. I'm Andrew Hutchison, and this is not an audiophile podcast. Over and out for another week, and we'll be back soon. Bye, everybody.